All right, so when we're multiplying, we change all mixed numbers to improper fractions. Remember that that was kind of optional for adding and subtracting, but for multiplying, you need to do it or you're going to be making stuff up. And put all whole numbers over 1. All right. Then this is the part that a lot of you skip or do incorrectly or think you're doing something else, right? And it can be called a few different things, but we're going to call it cross canceling. So we're going to cross cancel if possible, okay? If possible. Not always possible, and we can't make things up, right? Then multiplying is easy. We just multiply straight across. We do not need a common denominator. If you get one, it's not necessarily wrong. You're just going to be making your life more difficult because it's going to make your numbers bigger than they need to be. And then step 4 is like it was yesterday. Reduce a proper fraction. I probably could have already had this filled in for you at this point. And maybe, although we are doing it on all the ones here, change an improper fraction to a mixed number. Okay. And I say maybe because in the future, it depends on the situation, but we're going to do it on all these just to practice the concept of it. Notice one thing that's not on here is reducing the fraction. That still needs to be done, but if you do step 2 fully, you won't be able to reduce it. So sometimes people skip step 2 or only halfway do step 2, and then you still need to reduce it. It doesn't necessarily mean what you're doing is wrong. You're just making things more difficult on yourself. And this is where I think the disconnect on what you're allowed to do has come in some. All right, so let's look at A. Now, there is a difference between cross-canceling and cross-multiplying. If you were going to cross-multiply, that would look something like 3 over x equals 1 over 4, or something like that. And then you'd multiply 3 times 4, 1 times x, right? That's cross-multiplying. That is not what we are doing. When you are multiplying two fractions, because we get to multiply straight across, you can actually look at it as one big fraction, right? So let's think about it like that. Let's rewrite it as one big fraction and put 4 times 1 over 5 times 8. So now that it's 1, and we're not going to make it one big fraction on everything we do. I just want you to understand the concept here. Now I can reduce this because I can reduce the 4 and the 8. 4 goes into 4 once, goes into 8 twice. Then I just multiply the numerator and get 1. Denominator, 5 times 2 is 10. If I had started by multiplying straight across and got 4 over 40, that's fine. It reduces to 1 over 10. But if we cancel stuff first, we have smaller numbers we can deal with, okay? We good on that? Questions? All right. So on B, what's the first thing we want to do? Can I multiply 2 times 2? Yeah. We got to change the mixed number to an improper fraction. So I do 2 times 6 is 12 plus 1 is 13 over 6. Times 2 times 5 is 10 plus 2 is 12 over 5. Okay. Now, we're capable of multiplying 12 times 13, but we don't want to do it unless we have to. And we don't have to because we can reduce. If I can reduce vertically, you can always reduce vertically, and that is always legal. You absolutely cannot reduce horizontally, which I saw a lot of this morning. Vertically is fine because it's just the individual fraction, or cross-canceling is fine. The 13 and the 5 I can't do anything with. But 6 goes into 6 once, goes into 12 twice. And then now I just multiplied straight across. 2 times 13 is way easier than 12 times 13. And that's going to give me 26 over 5. Okay. Then make that into a mixed number. I'm going to grab my tea real quick. So this should be what, 5 1/5? Yes? Any questions? Okay. So Again, I can cross cancel. I can also vertically reduce, which is something that you probably want to do as often as you can. I can't reduce the 7/30ths, but I can reduce the 10/14. If you check that stuff before you start, it can make your life a little easier. So these are both divisible by 2. So this is going to be 5/7. Okay. So now I could do all this in one step, but I don't want to lose anybody. So, and some of you like to write extra steps so you don't lose yourself in your stuff. So basically now what I have is 7/30 times 5/7. Those are not necessarily difficult numbers to multiply, but I still don't want to have to do it if I don't have to. So the 7s I can cross cancel. 7 and 7, those become 1s. 5 goes into 5 once. How many times does it go into 30? 6. So then when I multiply straight across, I get 1 in the numerator, 6 in the denominator. So notice if we actually cancel before we multiply, then there's nothing to reduce in the end. If you, let's say that we changed it to 5/7, but then multiplied straight across, that's fine, but then I have to reduce a fraction with big numbers that aren't going to be as obvious to me. Okay, we good with that? What questions you got? All right. Oh, I'm so sorry. Put your hand up. Oh, yes, you could have. And so instead of reducing, you're saying, is that what you mean? Yes. Yeah, so if I have 7/30, and I think that's actually how I worked it this morning. But then I chose to do this way because I realized when everybody started working, everybody was missing the fact that we could reduce that. But absolutely. Here, would you do like 1 and 3? And then 1 and 2? That works as well. You're going to get the same answer in the end. Because it's all just canceling out. It's just what order you're doing it in. Totally legal. Good question. Thank you. What else we got? Anything? Okay, good to ask if things are legal or not, because sometimes y'all think they are, or it looks like it should be, and then it's really not. So let's do that here on D. I could reduce the 4/12, right? But as I look at this, I'm thinking I'm not going to, because I've got this 4 and this 4. I can skip over this guy. Totally fine, because we can multiply in any order. I can cancel these 4s out. They're just gone. Then I can do the 6 and the 12, right? 6 goes into 6 once, goes into 12 twice. Everybody with me? Then when I look at the rest of this, okay, so I got 25. Well, there's no 5s in the numerator, so he stays like it is. 4 is already gone. 7, there's nothing in the numerator that helps me. This 2, that's gone. That's a 1, that's a 3, but the 2 can become a 1, and this can become 4. If you cancel out a whole bunch of stuff, especially those of you that like to write microscopic, it might not be a bad idea to go back in there and circle what you're actually multiplying so that you don't lose anything, because that happened a lot this morning as well, is that they weren't getting the right answer, but they were leaving something off. So now when I multiply straight across, I'm going to get 4 times 3, which is 12. All right, then 7 times 25. If you're multiplying by 25s, think of money. You got 7 quarters. How much money you got? 175, exactly. And then we should always at least check and glance to see if we can reduce. Well, because hopefully we knocked everything out and we can't, but 175 is not even, so I can't divide by 2 or 4, but possibly 3. Is 175 divisible by 3? No. And can you tell by just looking at it real quick, even if you can't do the numbers in your head? What's the trick? Add them all up. You add the digits. 1 plus 7 is 8. 8 plus 5 is 13. 13 is not divisible by 3, so 175 is not, and we don't have to guess and check. Okay? It's like 27. 2 plus 7 is 9. 9 is divisible by 3, so 27 is. That way you know without guessing and checking. Okay? So that means I can't do anything else. That's my answer. Okay? Everybody good with that? All right. Cross-canceling, it can really make your life easier. And I know maybe a few of you are used to doing that, but for the most part, most students don't, or they do it wrong or make things up. Okay. Can I cross-cancel here at all? Or reduce anything? No. So I just multiply straight across, and I get 3 over, not 3, oh my gosh, I'm adding. Don't do that. 1 times 2 is 2. over 45. Yikes. Multiply. And that's it. Okay, super easy one. Any questions at all? All right, let's talk division. We're going to start the same way. Change all mixed numbers to improper fractions. And put all whole numbers over 1. Always do that so that you don't do something weird with fractions. Okay. Step 2 is KCF. What does that stand for? Keep, change, flip. All right. And so let's see. Keep, change, flip. Now, I would say about 100% of students can usually tell me that, but only about 80% actually do it right. Just because you can say that doesn't mean you're keeping, changing, or flipping the right things. So we got to make sure we know the right things. So you keep the first fraction, change the division sign to multiplication, and flip the second one, which is the reciprocal. All right. And then after you do that, after you have changed it to multiplication, then you cross cancel. You cannot do that first, which is something I saw a lot of this morning as well. So we got to be careful with that. I'll make sure you understand what I mean when we get here. Then we have essentially changed it to a multiplication problem, so we can just multiply straight across. Just like we did for multiplication. And then step 5 is the same as the rest. So reduce a proper fraction, always reduce. And maybe, depending on actual instructions in the future, we change an improper fraction to a mixed number. Okay. All right, so on A, here's what we don't do. I cannot cancel the 3's out. You do not cross cancel over a division sign. It's only after we change it to multiplication that we're allowed to do that. Now, we can vertically reduce at any point because that's just that fraction itself. So if I could reduce the fraction, I could do that, but I cannot cancel the 3's. And since I don't have a mixed number and I can't reduce, I'm going to go ahead and keep, change, flip. So I keep the first one, which is 3/5, change the division to multiplication, flip the second one, so that gives me 3/2. So then when we multiply straight across, we get 9 over 10. So this morning, somebody's like, why do we flip it? Well, to give you the kind of simplest answer so it makes sense to you, if I said I want to do 10 divided by 2, okay? Dividing by 2 is the same as multiplying by 1/2. So any division is the same as multiplying by the reciprocal. Both of those are going to give me 5. Okay, and neither one of those are, like that's not difficult enough for us to have to do that. But when we have fractions, that's what's happening. Okay, because dividing is multiplying by the reciprocal. Everybody good so far? All right. Can I reduce the 4 and the 18? No. Can I reduce either one of these fractions? The fraction itself. 4/9 I can't. Can I reduce 8 over 18? They're both even. And if I miss that, it's not the end of the world. Okay. But I can make this 4 over 9. So now I keep, change, flip. 4/9. Change it to multiplication, flip it, that gives me 9 over 4. So I really have a fraction times its reciprocal. Those cancel, those cancel. So is my answer 0? What's my answer? 1. Multiply a number times its reciprocal, you get 1. Okay. If you didn't reduce this first, and we had 4 over 9 times 18 over 8, it's still going to take care of itself because I would reduce that. I'd reduce that. And that ends up with 2 over 2, which is 1. So it still works, but which way is easier? It's a matter of opinion, but the more you can reduce along the way, the better off it is for you. Okay. What questions you got? All right. So I'm going to start by changing this to an improper fraction. So 3.5 would be what is an improper fraction? 7/2. Then I'm going to change to multiplication and make that 4/3. Nothing wrong with multiplying straight across right here, but I can reduce, which makes my life easier. That's 1, and that's 2. It's going to give me 14/3. Okay, reduce that if I can. I can't because I had everything else reduced. Make it into a mixed number. How many times does 3 go into 14? 4 with 2 left over. What questions we got? We good? Have some of you been doing fractions the hard way? Probably, yeah. And again, you were probably taught, I would assume you were taught it at some point, but then y'all try and avoid them, and I'm sure those poor elementary school teachers are just banging their head against the wall with fractions, so they probably just like, we got to move on. All right, whole number over 1. Always do that with a fraction, always. I do that myself, just so that we don't do something weird with it. Then it's just a simple keep, change, flip situation. So go ahead and do D. Be 18/1 times 3/2. So then if I just multiply straight across after I reduce, I get 27/1. Some of y'all would just write 27 there, which is fine. Some of you keep it as 27/1 because you already made a fraction out of it. That's fine. But in the end, it's just plain old 27. It's not, you don't necessarily have to write that stuff, but some of you will get there. All right, we good? Any questions? All right, you do E. You can do E without me. 6/1. Oh, yeah. More, or are you good? Okay. Did we not agree? Okay. Oh. This is fine. Where did the 9 come from? Oh, because yeah. Times 3 over 1. Yeah. That's it. Yeah, you're good. One over 8. Y'all agree? Is that what y'all got? Oh wait, no, that's right. Did you not do it?
Did it wrong.
Did it wrong. That's okay. 3, 4, 6, 7. Because you didn't flip it. Yeah. Okay. Any questions at all? All right. So let me talk to you about the practice a little bit. I'll come back. I know you're writing, but let me just say this real quick. If you're practicing, when you get here, when you get here, obviously you need to change that to a mixed number. When you get here, it's keep, change, flip, and then basically keep, change, flip again. So it's really keep, change, flip, change, flip. You're changing and flipping both. You don't have to do it in separate steps. Okay, but I will put this back so you can finish, and then you have the rest of the time to work on this. Make good use of your time.